All right, so this time, instead of having simple interest or regular compound interest, we're going to have interest compounded continuously. So in other words, it's just constantly compounding, which means if you try to use the regular compound interest formula that we've used already, there you won't have anything really to plug in for n, and that tips you off that this is the wrong formula for when it's continuous. So continuous is the key word. So here's our formula that we want to use. Okay, T is still time, R is still interest rate, P is still the principal or original amount borrowed or invested, A is still the final amount, the accumulated amount, and E, well, E is not a variable. E is an irrational number. You know how pi is equal to 3.14, blah, 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 and it goes on forever and it doesn't repeat. Well, E does a similar thing. It's 2.7, blah, 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 and it goes on forever. Okay. So you don't have to figure out P. P is just that number. So we want to know if we start with 1100 and the interest rate is 0.065 or 6.5%, and we want to do this for 5 years, then what's it going to be? So we're going to go to the calculator and we'll say 1100. Now this E, the calculator does it. You can either, it's right above the divide sign, or right here, it's e to a power. Since I want to do it to a power, I'll just go second and then that one. Or you could go second, E, and then use the exponent key. It would be the same thing. And then 0.065 times 5, and you get $1,522.43. That's how much money there'll be. So that means $422.43 of interest. So anyway, that's how it's done. Okay, new one. There's some similarity here. We're still talking about continuous interest compounded continuously. So that means we're going to be using the Pert equation. Okay, so Mr. and Mrs. Davis hope to send their son to college in 11 years. How much money should they invest now? So we're looking for P. So I'm not going to plug anything in for it. At an interest rate of 9% in 11 years, compounded continuously. So that's why we're using that formula instead of the one with the N, in order to be able to contribute $7,500 to his education. So they're just going to dump in one lump sum. They're not going to make like monthly payments like most people would. That involves a different formula. Okay, so notice we could plug all of that into the calculator and get a number. So by the same token, we could also just say, all right, well, let's just divide by that. So that's gone. And then we're left with P. Let me do it lower so it's easier to read the computer screen in a moment. P equals, okay. And then it's time to go back to the calculator, your friend and mine. Okay, so we want to go, I'm going to do a big fraction. 7,500 over e to the 0.09 times 11. Yeah, 11. And okay, the answer is less than the 7,500. That makes sense because it's going to, whatever they invested, it's going to be growing to become 7,500. So $2,786.83. That would be the answer. Okay, so now find the present value of investment earning compound interest. Okay, this doesn't say anything about continuous, and in fact, it does say how often it's going to be compounded. So we're going to be back to the A equals P times 1 plus R over N to the NT formula, and of course you get that right there. All right. Let's see. So to help with her child's college fund, Karen needs to invest. Assuming an interest rate of 2.27% quarterly, how much would she have to invest to have 64,700? So we want to end up with 64,700. And the question is, what does she need to invest, P, to make that happen? If she does it in one big lump sum, which is how pretty much nobody does it. But this is just giving us practice with this formula. And quarterly means 4 times per year. And we're going to do this for 13 years. Okay. So like I said on the last one, this stuff here multiplied by P, that we could plug that whole thing into the calculator and get a single number. And therefore, we could divide. Oh, hey, there's my dog. Hey, Zoe. We could divide by that big thing. And then divide by the same thing over there, because I don't feel like writing it out again. All right, and then we get P equals, and then these are going to cancel, which was the point of doing this. And now it's time to go to our good friend, Mr. Calculator. Okay, so I'm going to do the fancy fraction again. And let's see, 64,700. It's going to go a lot farther than the 7,500 from the last family. Okay, and then we're going to divide that by 1 plus fraction 0.0227 over 4 raised to the 4 times 13. They're going to need to plop down $48,206.57 in order to meet their goal if they just do one deposit and leave it there for 13 years. Again, pretty much everybody doesn't do that. They say, well, let's put in like 200 a month or something and do that for 20 years or something, and then you end up with a lot more. But this formula doesn't handle multiple deposits. That'll be the annuity formula, which is coming up very shortly. Okay, now this time it says an investor wants to save money to purchase real estate. She buys an annuity with monthly payments. Okay, so she's going to be making deposits every month instead of like the last several problems where it was like, okay, let's just dump in money one time and then let it grow. And that's it. This is much more realistic. This is, okay, we'll just keep adding money in every month and that'll be cool. When you do that, when you make these equal regular payments, those are the key words, equal regular payments, you have an annuity. That's annuity, okay? And we've got our formula for annuity right here, okay? So as you can tell, there's certainly some similarity to this formula here that we were using, but it's not all the same. Okay, so let's get down to it and start using this thing. Okay, so first thing is the M. That's what your that's what your regular equal payment is going to be, and in this case, that's $67. Okay. Then we'll do 1 plus the interest rate of 5% divided by the number of compounding periods in 1 year. Well, the number of compounding periods in 1 year coincides with the number of payments in 1 year. And since this is monthly, it's going to be 12. And that's usually how it is. And then N is 12 again. And we're doing this for 16 years. And we're going to divide all of that by R over N again. And that's what we type in the calculator. And we just got to make sure it looks just like that. Okay. So I think I'm not going to clear my screen, and then it'll be easier to see what's going on. Because, well, it shouldn't be too hard to figure out. Okay, now, when I wrote it by hand, I had these brackets and these parentheses. On the calculator, we're only using, whoops, wrong button. We're only, I guess it is relevant, only using parentheses, no brackets. If you use brackets, you're telling the calculator, hey, we're doing a matrix. And that's not at all what we're going to do in this class, okay? When you need them, they're very cool. We don't need them in this class. So you'll notice I'm just typing it out exactly the way it appears on the the way we wrote it out by hand. 12, 16. Yeah, I think that's okay. Let me just kind of look around. Yeah, I think it's okay. All right, so you're going to end up with $19,647.27. So about $19,500 after just putting in 67 bucks a month for 16 years. Okay. Now, how much money actually got put in? Okay. $67 times 16 years, 12 times per year. So you're putting in $12,864. So how much interest is obtained? So you're going to get $6,833.27. They didn't ask you to find that, but I think it's interesting. No pun intended. Okay, so Milan wants to, that's a pretty name, wants to save money for his, I guess it's the guy's name, daughter's graduation gift. So he deposits $750 at the end of each year in an ordinary annuity that pays 2% interest compounded annually. All right, so find the total value of the annuity at the end of the first year, second year, third year. So that we're going to do this very similarly to the last problem, except we're just going to do it 3 times. So let's see, 2%, 750 annual. Got it. Okay. So let's start typing here, or writing, I should say. Let's see. So we're going to say, all right, so 750 bucks, that's the payment, that's the M. And let's see, then we're going to go 1 plus an interest rate of only 2%. And this is, he's only doing this annually, 1 time per year. So N is 1. And he's doing this for, that's right, 1, 2, 3 years. Okay, so that's going to vary. The time will vary, and so we'll represent that with a variable. And then we need the -1 there. All right. And then the 0.02 over 1. Okay. And you can do it on the main screen, the calculator, but I'm like on a previous video, I'm going to do it, the very cool way, and go like this, and just type in the function. All right, and then we're going to go, how to say 0.02 over 1 is the same thing. Well, okay, I'll type it, whatever. And then to the 1 times t. Okay, and so I don't really need to put that 1 there. -1 parentheses over 0.02 divided by 1, which is just 0.02. Okay, so I've got my formula in there. And so let's see, let's go to the table. And so after 1 year, $750. After 2 years, $1,515. After 3 years, $22.95, 30. Let me make sure I'm answering the exact question they asked. Find the total value. Okay, yeah. Total, yeah, okay. So I did it correctly. I thought, maybe they asked just for the interest. Okay. But that's not what you need. So yeah, so those would be the total values right there. Okay, and that's how I use the annuity formula.